Today we're going to be talking about the distributive property. Our objective today is I will be able to use the distributive property to simplify algebraic expressions. Now that's our objective, and we're going to look at this objective a little more thoroughly. This will be done by both distribution of a constant and a combination of like terms, and that's if that allows an example of combining like terms or as an example of simplifying a numerical expression. But we're going to focus in on using the distributive property. When you hear distribute, you should think multiply. When you hear distribute, you should think multiply. So let's get this lesson started. Here we're going to talk about the distributive property itself. Remember what I said in the introduction slide. I said that when you hear distributive or distribution, you should think multiply. Because what happens here is we have an expression like right here, A parenthesis B plus C. Now you should have had pre-algebra and you should not be unfamiliar with this, but we need to review it. And what we do is we distribute this A, so we go A times B, and then we distribute the A to the C, so we go A times C. So another way to get rid of parentheses is to use the distributive property instead of adding these two things together, or say you can't add those two things together, as we're going to learn. If they're not like terms, we can't add them. We can distribute to get rid of those parentheses. Now, it works if that number A is on the outside also, or to the right of, and we would distribute to the B, and we'd go B times A right here, and then we'd go distribute the A to the C and go C times A. Notice how the A is on the other side, or the right of the B and the C this time. Now this works also over subtraction. We can distribute over subtraction A times B and A times C. So we have A times B minus A times C instead of addition. So this works over both addition and subtraction, and it also works if the number's on the right or the left of the set of parentheses. And this should be a subtraction sign right here, so you should fix that. This should be B times A minus C times A. That should be a minus sign right there, so fix that if you will. Now here we have a couple of numerical examples. Instead of adding these two numbers together inside of parentheses, I'm going to distribute here. So I'm going to go 5 times 25. And I'm going to add that to 5 times 3. 5 times 25 is 125, and 5 times 3 is 115. Add those two together, that gives us 140. So there's another way to simplify an expression with parentheses. Now we can see an example here where the number on the outside of the parentheses is to the right. We still distribute. We'll go 10 times 5. And then we'll go plus 8 times 5. 10 times 5 is 50. 8 times 5 is 40. And add those two together, we get 90. So there's another way we can simplify an expression using the distributive property. We're going to see how the distributive property works in more examples in this lesson. Here we're using the distributive property. Example 1. Simplifying a numerical expression. The first numerical expression we have is 6 times the quantity, 1/2 plus 1/3, close the quantity. So we can do this one of two ways. We could try to add these fractions together, or we could use the distributive property. I'm going to show you how to use the distributive property here to do this. First, we'll distribute the 6 to the 1/2. And we'd write that down as 6 times 1/2. And we'll add that to 6 times 1/3. Now, 6 times 1/2, that's 6 over 2. 6 times 1/3 is 6 over 3. 6 over 2 simplifies to 3, and 6 over 3 simplifies to 2. So we add those together, that gives us 5. So we can see there's an easier way to work with fractions. Since 2 and 3 were divisible or can divide into 6, or 6 is divisible by both 2 and 3, this was a very easy problem. It ended up being a whole number. Here, instead of trying to multiply 25 times 198, we're going to break 198 down into two different numbers. We're going to rewrite it with subtraction, and we're going to write it as 200 minus 2. That's another way to write 198. 200 minus 2 gives us 198. And what we'll have to do is multiply both of those numbers by 25. So here's an alternate way that you can do some math quickly. We have to multiply both of those by 2 because they both make up 198. 25 times 200, well, 25 times 2 is 50. We have to tack on 2 zeros, so that'd be 5,000. We're going to subtract away 25 times 2, which is 50. And 5,000 take away 50, that's very easy. That's 4,500. No, it's not 4,500. It's 4,950. It's 4,950, not what I said before. It's 4,950. So there's using the distributive property to do some mental math and simplify something with fractions very easily. Using the distributive property, example 2t, using mental math. Take 1. Action. We continue our work using the distributive property, and we have example 2t using mental math. Similar to part B of example 1t, we're going to use mental math to solve this problem. We're going to write it out, but I'm going to show you how it ends up being mental math. Very easy to do. Find the total cost of 4 CDs that cost $12.99 each. This is a basic math problem which tells us we're going to have to multiply 4 times $12.99. If we think about writing $12.99 as 13, take away 1 penny, or 0.01, and then we multiply both of those by 4. Much like we did in part B of example 1t. 4 times 13 is 52. 4 times 0.01 is 0.04, or 4 pennies. 52 take away 4 pennies is 51.96. So the cost of those CDs is 51.96. Now this could be mental math if you can do that in your head. Instead of reaching for a calculator, you can impress your teacher or your parents or your grandma or your grandfather by doing something in your head. We're still using the distributive property in example 3t, simplifying an expression. More precisely, an algebraic expression. The directions are to simplify. So in part A, we need to simplify 2 times the quantity x plus 4. So what we have to do is distribute the 2 to the x, so we end up with 2 times x. And we have to distribute the 2 to the 4. We just write the addition sign down for now, 2 times 4. And then we can simplify that a step further by writing this as 2x plus, and then doing this multiplication, 8. So this simplifies to 2x plus 8. Moving into example B, we have to distribute the 3 to the x to give us 3 times x. And 3 times 5, separate them with a subtraction sign. 3 times x simplifies to just 3x, and 3 times 5 simplifies to 15, so 3x minus 15. Here, we distribute from the right-hand side, where we go 4 times 5. Actually, we'll write that as 5 times 4, minus 3x times 4. We multiply here, we go 5 times 4 is 20, minus 3 times 4 to give us the minus 12, and put the x on there. 20 minus 12x. Finally, in example D, we have to distribute the 3 to the 4m, 3 times 4m, and then 3 times 7. And it'd be minus 3 times 7. 3 times 4 is 12, and that gives us 12m, minus 3 times 7, which gives us 21. So there's using the distributive property to simplify an algebraic expression. I suggest to you that until you not miss the second distribution, use these little arrows to help you out. So I do this one, write it down, and then I do this one and write it down, and then do the multiplication. This might not even be a step that you need to do eventually when you really get good at it. We're continuing to simplify algebraic expressions with the distributive property. In example 4t, we're going to take a look at using the multiplication property of -1. The simple way to remember this is going to be right here. When you distribute a -1, change all of the signs. So all of the signs inside the parentheses are going to change. We're told to simplify. In part A, this would be read the opposite of the quantity 5q minus 6, or you could read it as negative 1 times the quantity 5q minus 6. And why we change the signs is because of the multiplication of prop negative 1. When you multiply by negative 1, you change the sign. So when we write this out, negative 1 times 5q, we distribute that negative 1, and then negative 1 times negative 6. Now, negative 1 times negative 5q gives us negative 5q, because negative 1 times negative 5 is negative 5. The negative 1 times negative 6 is a positive 6, and that's going to make that sign an addition sign, because the sign of these two factors is positive. It gives us a plus sign in between our two terms. Now here we have an example B, negative 1 times 3x plus 4, the quantity 3x plus 4. So we have to distribute negative 1 times negative or positive 3x and negative 1 times positive 4. When we do that, that gives us negative 3x minus 4. 1 times 4 is 4, and a negative times a positive is a negative, so that sign is a minus sign in there. Now notice, from the original to the second, all we do is change the signs. If this was positive, we made it negative. This was minus, we made it plus. Here, this was positive, we made it negative. This was plus, so we made it minus. When you distribute a negative 1, you change all of the signs. And that's how you distribute a negative 1. Since we've looked at how the distributive property is just basically using multiplication, we need to learn how to combine like terms, which can use the distributive property. First off, a term is a number, a variable, or a product or quotient of numbers and variables. Okay? A term is a single thing. Let me show you a couple examples of terms. Here's an example of a term. 2x squared. 2 times x squared. That's an example of a term. There's no addition. There's no multiplication. 1/2 x. This is a second example of a term. 1/2 times x. Here's a third example of a term. 5w. All of these things are terms. They're the product or quotient of numbers and variables. Now, if we look at this expression right here, this expression right here has three terms. 2x is the first term, 5y is the second term, and 7z squared is the third term. It has three terms. Right now, not so much is it important that you can identify it as having three terms, that it has separate terms that may or may not need to be combined. Remember, this would be the first term, this would be the second term, and this would be the third term. Now, like terms contain exactly the same variables with exactly the same power or exponents on those variables. If we look at this example here that has three terms in it, this has 2x, this has 5y, and this has 7z squared. They have different variables, so none of these are like terms. If we wrote this down, 2x plus 4x, this has two terms, and 2x and 4x are what we would call like terms. Okay, you got to understand that. Like terms you're going to learn are going to be able to be combined. In the previous slide, I was talking about like terms, and here we have 5x plus 4x, and we have the single term 9x. Remember, this would be two terms, and this would be one term. Now, over here, it says these two expressions are equivalent expressions. And the reason they're equivalent expressions is because if we have 5x plus 4x, we could write that like this. 5 plus 4, with the x on the outside, what they have in common, we add those together, that gives us 9x, and 9x is equal to 9x. Remember, you can only add like terms, and since these are alike, since they have the same variables with the same exponents, they can be added. Here's a good word to learn right here. This is a very good word to learn right here. Simplest form. That phrase, that's a good word to learn. Understand what it means. It means that an expression does not have any like terms to be simplified. Simplest form means that an expression does not have any terms to be simplified. Now, a coefficient, let's talk about that. A coefficient of a term is the number factor. A coefficient of a term is the number factor. In 15x, 15 is the coefficient. It's the number in front of the variable. So to take away from here, we have equivalent expressions are formed when you combine like terms. So we could write 5x plus 4, or we could write 9x. Things are in simplest form when there are no other like terms to be simplified, and the coefficient refers to the number in front of the variable. Simplifying algebraic expressions. We're continuing our work here with the distributive property. Example 5t, we're going to learn how to combine like terms, and we're going to do that with the distributive property in mind. In example A, we have negative 2w squared plus w squared. First thing you need to know that these are like terms because they have the same variable with the same exact exponent on it. So the coefficient here is negative 2, and since there is no coefficient, we assume that coefficient to be 1. So we can rewrite this using the distributive property in reverse, really. Negative 2 plus 1 with the like term on the outside. And then we add these two. Negative 2 plus 1 is negative 1. And that would be w squared. And technically we don't need that 1 in there, so this could just be negative w squared, or the opposite of w squared. In example B, we have negative 5x plus x. Again, like example A, there's no coefficient here, but the coefficient is 1, and they are like terms. This has a base of x, this has a base of x. The variables there are, or the exponents, there is no exponent. We assume it to be 1, so it is the same. So using the distributive property in reverse, we take the coefficients, and we do whatever it tells us to do, negative 5 plus 1 in this case. We put the variable term on the outside, or the variable part on the outside, and we simplify this. Negative 5 plus 1 is negative 4, and that would be negative 4x. In example C, we have 2x plus 4y. Now, what you need to notice is that this is x and this is y. These are not like terms, so we can't add them. Don't try to add these together and make this 6xy or 8xy. Don't try to put these together. We cannot add them because they are not like terms. And that's important to be able to recognize. Simplifying algebraic expressions. The word quantity indicates that two or more terms are grouped with parentheses. So a key word from this lesson today, another key word among the many, quantity. It indicates that two or more terms are grouped together with parentheses. And since this lesson is on the distributive property, it's going to be important to know a key word when you're going to have to use that parenthesis from a problem-solving situation. So example 6t, writing an expression. We need to write an expression for the product of negative 6 and the quantity 7 minus m. This is pretty easy to do. We got this one key word right here, the product of negative 6 and the quantity 7 minus m. So we're going to multiply negative 6 and this quantity 7 minus m. So we do that by negative 6 times the quantity, parenthesis, 7 minus m. We could simplify that by not using a dot there. That would be negative 6 times 7 minus m. And if we needed to, we could simplify that by using the distributive property. But in this case, we're just asked to write the expression. We're not asked to simplify it.